Today we're going to be looking at section 2.2. And what we're going to do is we're going to kind of start looking at and analyzing the graph of what we call a quadratic equation. You're not going to have to graph them yet, but we're going to analyze the graph of a quadratic equation, which is ax squared plus bx plus c. So the first thing I would like you to do in your notes is make a tiny little, not tiny, but make a little grid here. An x, y axis. And I'm going to give you a quadratic equation that has an a of 1, a b of 0, and a c of 0. So what that would look like is y equals 1x squared, and then plus 0x plus 0. And the 1 isn't really necessary, so we call it y equals x squared. So you really don't see any numbers on there. This is called the parent function. And every number that we put in front of that x squared or add to it does something to the graph, but they all get compared to the parent function. So let's go see what the parent function would look like if we went and plotted some points, and then let's go look at it on a graphing calculator. So in order to see what it looks like, I have to put some stuff in for x and see what comes out for y. And remember, to get y, I'll square the x. So let's begin here. Pick any number in the world. I'm going to pick the number 0. My y value that goes with 0 would be 0 squared, which is 0 times 0. So this point, when I put in a 0 and a 0 comes out, is on my graph. And 0, 0 is dead center, the origin. Let's go put some tick marks on our graph while we're at it. All right. So my next favorite number in the world is the number 1, as it's so easy to work with. And when I put in a 1 for x, which means I go over 1 on the x-axis, I need to know how far up or down to go on the y-axis. To determine that, I square the 1, which is 1 times 1, which is 1. So what this tells me is, when I put in a 1 for x, or go 1 to the right on the x-axis, I need to go 1 up on the y-axis, and I get this point right here. Now I'm going to put in the number 2, and then I'm going to play connect the dots when I'm done. When I put in a 2, I need to square it to get the y. 2 times 2 is 4. So what that tells me is the next dot I need to plot is 2 to the right, because it's positive, and 4 up, because it's positive. So when I do that and I go 2 to the right, and 1, 2, 3, 4 up, I end up right about here. I can kind of see what's happening over there on the right-hand side. If I put in a 3 and square it, I would get 3, 9. So the next thing I'm going to do is put in a negative 1, and I'm going to square it. And I put it in parentheses because I need to square the entire negative 1. I need to do negative 1 times negative 1, which is 1. A negative times a negative is a positive. So this tells me I go 1 to the left and 1 up. And let's do one more. Let's put in a negative 2. When I put in a negative 2 and square it, I'll do negative 2 times negative 2, and a negative times a negative gives me a positive, and 2 times 2 is 4. So when I put in a negative 2, I go up to 4. And what you're going to see here is some symmetry, because whatever happens on the right-hand side, when I square negatives, I get the same thing as when I square positives. So we get this U shape, kind of looks like a smile, and it goes like this. Now let's go see if that's what it looks like on my graphing calculator for a moment. So you don't need to go get a graphing calculator. I just want you to see how this works. So if I hit my y equals button and I go tell my calculator to graph, and why won't it go? Come on. Just a second, I'm going to see why my calculator's not activating here. Oh well, I can't use my calculator in this lesson. I'll have to do it in another one and see what's wrong with it. Yeah, it's not responding. So maybe it will if I go click on my computer. So just give me a minute here. I'm going to walk over to my computer and see if it'll allow me to enter it from my computer. Nope. All right, so anyway, you'll just have to trust me on that one, that's what the graph of that looks like. So let's go back and discuss a couple things about this parabola. You'll notice that it opens up. You'll notice that it looks. All right, I paused my video to get the calculator to go out, and I got it. So by the way, to get to this window, I hit the y equals button in the top corner. And we're going to go see what y equals x squared looks like. And if you have a graphing calculator, you might want to take a look at that also. So I'm going to have that parabola come down, and it looks just like the one I made. Now what we're going to do is investigate a little bit here. I'm going to go back to that y equals button, and what I'm going to do is put some other numbers in front of that x squared to see what happens. So I'm going to leave that one on there. I'm going to leave that parent function there. And what I'm going to do first is just put a negative in front of it. So watch, I'm just going to go negative x squared. And let's think about what would happen here. Instead of the y's equaling x squared, like 4, when I put in a 2, they're going to equal the opposite of that. So if you can kind of think about it, if positives on the y make me go up, negatives make me go down. So when I hit graph, instead of a smile, you're going to see a frown. The reason you're seeing a frown is because that negative's in front of it. Notice how it's the exact same thickness, though, or width. It just flipped over. So let's try a couple more on here. I'm going to clear this out and clear this out. If I were to graph 2x squared, and then let's just say plus 3, this will also make a parabola. Well, it looks like a smile or it looks like a U. Let me hit graph here. And it's going to make a smile because I put a positive 2 in front of that x squared. And then what happened is it went up 3 because I hit plus 3. Well, let's go investigate. What if I want the same one, but I want it to open down and make a frown? Then I'd enter negative. I'm going to still hit plus 3. And what I'll get is the exact same parabola, but that negative that I put in front of that 2 causes it to flip over and make a frown. So you're going to see a red parabola flipping upside down. So let's go discuss what effect that lead number had on the graph and a couple other things about it. First of all, this shape right here is called a parabola. The graph is called a parabola. The function or the equation right here is called a quadratic equation. When there's no numbers in front of it, we call it a parent function, and its graph makes a parabola. All right, so what I would like to do now is talk about, again, the opening up and opening down, and we'll get that in your notes. So let's put a little bar right here. And first, we're going to just discuss what the effect that A had on the graph. See if I can move this down a little bit. There we go. So if that lead number, which we call A, is positive, like 2 or 1, 5, 9, any lead, like 2x squared plus a bunch of crap, or a half x squared plus a bunch of stuff, or 8x squared plus a bunch of stuff. Anytime that lead number in front of the x squared is positive, think positive things make you smile, it will open up and look like a smile. This would be called a parabola that opens up. If we put a negative number in front of it, and you saw that, it caused it to flip over. So think negative makes you frown, or negative opens down. Okay, so these make smiles. These over here, negative x squared plus some stuff, or negative 3x squared minus some stuff, or negative 1/2 x squared plus some stuff. These are all going to cause frowns, or cause it to open down. All right, so that's all we're going to practice today, is just kind of knowing what these words do to the graph and what happens with the graphs. So we're going to go analyze one of them, and I'll show you the type of questions that are on your worksheet. There's only 4 of them, and I'll show you what you're required to do. Right now, you might want to pause this and go grab a graphing calculator because you'll need one. All right, so you might want to pause the video and go grab a graphing calculator. So let me put a quadratic equation down, and we're not going to graph it by hand yet, but I'm going to say y equals 3x squared minus 2x plus 5. Again, this makes it a quadratic equation. Its graph will be, what do we call those graphs? Its graph will be a parabola. It's spelled like parabola. So before we go graph it on our graphing calculator, let's see if we know the words for it. So its graph will be a parabola. And if I were to say, what's A? A is this lead number in front of the x squared. So we'd say A equals 3. And then let's see if we know what that tells us. Since A, which is 3, is positive, what does that tell us about the graph? I'm going to put that in a different color. You might want to pause this and go grab a colored pencil or a highlighter and highlight these words. That'd be a great idea. Actually do that. Pause this and go grab a highlighter from on top of the back cart. Anyway, since A is positive, the parabola, think positive smile, the parabola will open up. So I know it's going to look like this. And it will look like a smile. Now, if that was a negative 3, it opened down, and it'll look like a frown. Since, well, let's talk about something else about that 3. Since 3, we're going to compare it to the parent function. Remember, the parent function is y equals x squared. Let's see if we know what that 3 is also going to do to it. It causes it to open up, but since it's bigger than 1, and since y controls this movement, what that 3 also does is it stretches the graph to 3 times its height. So it's kind of like if I grabbed you and put you in a stretching machine and stretched you out to 3 times its height. Your height, you'd get very skinny. It's like a piece of gum when you stretch it. And so what happens is the graph gets narrower than the parent function, not wider. And we're going to have to put that in our notes also on the previous page. So it'll get narrower than y equals x squared, and remember what that's called, which is the parent function. So your worksheet is going to be similar to this, where you're going to be filling in the blanks, and what's going to happen is I'm going to just mess with this lead number and ask you some questions. But we're going to go graph both on the graphing calculator in just a moment. What I'd like you to do, though, is in your notes, I'm going to go back a page. Under here, we need to write something else too that I forgot. And we need to also discuss how A affects the thickness of that graph. So if that A, basically an absolute value, but if you look at that A, and I'm going to, absolute value means to take the positive. If it's greater than 1, which means it's bigger than that parent function's lead number in absolute value, like if it's a 5 or a negative 6, or 8 or -8, what happens is it stretches the graph and it makes it narrower. So it gets very skinny when you put a bigger number in front of there. It's weird because you'd think a big number and make it fat because we think big and fat, but it doesn't. It stretches it this way, like I'm pulling on you. It'd make you skinnier. If that A is less than 1, like a half or a fourth or even negative a half, all right, if you see a fraction like that that's less than 1 in absolute value, what that means is I'm going to squish you to a half your height, and you're going to pop out the sides, and it's going to make you wider. Let's go confirm that on our graphing calculators. So I'm going to go take that last one I had. I'm going to go clear this out. So I'm going to go back to my y equals. I'm going to hit clear. You should do this too if you have a graphing calculator at your desk. And I'm going to enter the parent function because that's the one we compare everything to. Let's go take that one we just did in the notes on the second page. It was 3x squared minus 2x plus 5. And let's see if that gets confirmed here. 3x squared minus 2x plus 5. According to what we wrote, they're both going to make parabolas. They're both going to open up with a smile because they both lead in positives. But the one that's going to get graphed in red, the second one, has a 3 in front of it, and it's going to stretch it to 3 times its height. Let's go see if that happens. So there's the parent function in blue. The other one will pop up in red, and you'll notice that it got a lot skinnier. It shifted around also, but you'll notice it got skinnier. And just before we quit here, let's say we take that parent function and put a -1/4 in front of it. And let's discuss that, and then you can go grab the pink worksheet. If I put a -1/4 in front of it, first of all, that negative is going to cause a frown, and it's going to go down. That 1/4 is going to squish it down to a fourth its height, and it's going to kind of pop out the sides, and it's going to get wider. So now I'm going to have another graph on there. I should go in purple, and look at what happened. It flipped over because of the negative, and look how fat it got because of the 1/4. All right, so that's just the basics of the graphing. And let's go in your notes. Right here and right below this one, we're going to graph the parent function on the graphing calculator, which I just did. All right, so let's go put a graph. Y equals x squared is just this normal average Joe. And when I graphed the other one, in red, the y equals 3x squared plus 2x, what was it? 3x squared plus minus 2x plus 5. Again, you're going to graph these on the graphing calculator for now. It moved it over here, and it got really skinny. And that's what you'll be doing on your worksheet. Go grab the pink one. It's number 2. Have a good one. Peace out, Girl Scout.